Hi guys, welcome to our lecture 10, and in our lecture 10 we are going to discuss the anode now that we have discussed the cathode in our lecture 9. Now we see that electrons are being produced in the cathode by thermionic emission within the filaments, but then they're being accelerated to the metal target, and the metal target is what is called the anode. The anode is the spot where the X-ray or the actual production of X-ray occurs. Now, anode this is our anode. Now this is our anode look like. We have produced the electrons within the cathode. We have accelerated them now to the anode. Now, upon reaching the anode, they interact with the anode. After interacting with the anode, then we expect the X-ray now to be produced. Now, when you look at the anode, you can see this track. This one is called focal track. At this point, we have the focal spot. And then we can see we have the two motors here which are able to rotate this anode so that to reduce the production of the production, to make the anode tolerate the heat. Now this anode is placed at an angle called anode angle. It is normally placed at an angle called anode angle, which you can see. Now this anode angle, the larger we increase the anode angle, the larger the field of the beam and the larger the actual spot. And when the actual spot is large, then we also expect the effective spot to be equivalently large. Now, the vast majority of energy of an electron, as we have said, actually 99% are being converted to some other forms. We only use 1% to produce X-rays. Because when you see how these energies interact, when the electrons interact with matter or tungsten, what happens is that due to change of direction, or due to that attraction, the speed will reduce. When the speed reduces, the speed that which it was coming with is as a result of kinetic energy, meaning the kinetic energy will reduce. Now the amount of kinetic energy that is reduced, it is not going at waste. Those are the ones that are being converted into heat and the X-ray itself. Now within that sphere, X-ray only form 1% of the total kinetic energy that is with which the electrons are accelerating. Now, when you increase the anode angle, then we expect the beam to be very large. And when the beam line is large, then we expect it to interact with the anode at a very large space or very large spot. And once that happens, then automatically the effective spot also is going to be large. Now, the heat normally is being removed by some mechanism to ensure that the anode integrity is maintained, and always the means of heat transfer that are used in the cathode is through radiation, conduction, and even convection. But also a pool of oil also is used to conduct heat there. And 10% uranium is always added. It's always added to the anode. It's always added to the anode track here to sustain the integrity. It's always added to the focal track to prevent the tungsten from cracking. And the heat can also be controlled by short exposure. the tube current. You also can do it through the use of tube current and as well as the tube voltage. Because if you increase the voltage, automatically you're going to increase the kinetic energy. And when you increase the kinetic energy, what we expect high heat, high amount of heat. When you reduce the number of electrons being produced, then the interaction of electrons with the cathode or with the anode is going to reduce. And therefore, when it reduces, then we expect a reduction in the heat energy. And this one also can help into the sustainability of the integrity of this anode. But what matters is you must understand what you want to image, the area you want to image, and how you want to do it. Therefore, it will inform what type of beam or the quality of the beam that you want. That one also will be informed by the angle, the anode angle that will be effective for the production of the desired beam quality that is able to give you the images that you expect to have. Now that is all about our lecture 10, that is anode. We look forward to discuss lecture 9, where we are going to discuss about the other parts of cathode, the other parts of X-ray tube. Thank you and have a nice time, and feel welcome to the next lecture. And remember to subscribe and maybe hit the bell button so that every time when we upload any lecture, then you'll be able to understand. Also give a comment so that we appreciate, we get that energy to foster ahead by so producing more energy, more lectures. Thank you very much and have a nice time.